Hello, and welcome to the Rubber Duck Dev Show. I'm Chris.
I'm Kristen.
And I'm Andrew.
And tonight, we're going to talk about scaling all the things. Not fish, but, like Postgres and Rails.
That's
And
descaling.
yeah. So we're going to talk about how to make your stuff bigger without making your life harder. But we are excited to have Andrew Atkinson here tonight. And we are going to be talking about a lot of fun stuff. Chat, I hope you brought your questions because this is the man to pick the brain of if you want to know how to scale stuff. But before we get to that, week in review. Creston, how was your week?
Pretty busy. I always say that though. Speaking of scaling, one thing I was helping a customer with is actually scaling or distributing DNS queries, like using weighted models to pick which DNS server to go to. It's interesting, there's not a lot of services that provide the ability for DNS to actually direct traffic to one or more web servers and then do health checks against them. Like I know AWS Route 53 does, and I know that Cloudflare, my understanding, they do it. But a fair number of other DNS services just don't provide the functionality. And for me, like since I've started using that, I mean, that's been great to me for helping scale your site, keeping it up. But that's some of the stuff I focused on. What about you?
I had a lot of it was another one of those primarily admin weeks, and I just got to do a little bit of key
And by
tickling for
admin, you
some.
don't mean systems administration. You mean
No, I mean people administration.
people and paper pushing.
Yeah, all the fun things that we get into dev for, But yeah, I'm spending a lot of time with our enterprise clients and kind of standing in the gap between the tech speakers and the English speakers and doing a lot of translation work between those two groups of people. So I actually enjoy that. Taking tech speak and helping non-tech people understand it, and then taking what they want to do and helping the engineering side of people understand, well, this is what it means in programmerese, guys. So it's kind of a fun challenge for me. But yeah, I didn't get to do a lot of actual programming this week. A couple little minor bug tweaks, but if that's where the company needs me, that's where they need me. So that's what you do. So how about you, Andrew? Anything fun and exciting?
Yeah, I was thinking of two things, I guess, one technical and one less technical, but I think also still really important. And the technical one, ironically, is actually more about Elasticsearch than Postgres, which we're going to talk about today. But we also use Elasticsearch where I work pretty heavily for the application. And something the team I'm on now is more of an infrastructure team, and something I've never actually been able to do in my career, but have always been interested in doing is these disaster preparation and readiness exercises. And we're actually doing that now. So we did a kind of a simulation of a region level failure last week in a non-emergency situation. So we could just take our time, write up some documentation, or make sure our documentation was good. And I worked with another engineer on the team to go through that, and it was really a good exercise to go through it, and it felt good to reveal places where we had missed covering things, and then build some mutual understanding about how that might work in an emergency ahead of time. So I thought that was useful, and we're doing a similar exercise for all of our databases, which includes Postgres and Redis, and yeah, I think it's we did have some in place already, but we're kind of trying to take it up a level and then help grow the knowledge on the team. And the non-technical thing actually just today was we have a remote first company, and we have employees, I think in 11 countries. We have employees though all around the United States. And it's really hard to work remotely. I don't know if you guys agree or disagree. We feel like it's pretty difficult, and it's difficult to do it really well. And there's a lot of companies that have a lot of great information about it. I'd say our current company is, we're trying to kind of go to the next level and make it more deliberate and create more intention and practices and tools and processes and that are more mindful of improved remote work. And so today we had a meeting where we are going to be experimenting with modifying our kind of new employee onboarding. And I was able to contribute some ideas for that were more remote work oriented. And we're going to be able to actually try them out with real people and real managers and real employees starting. And I think that's fun too.
Oh, that's neat. Because you're right,
So
that's a tough nut to crack. It's hard to do that. But a lot of companies just have to because of the way development works anymore. And honestly, that just got my brain thinking that might actually be a good show. See if we can find some people who are experts in that and talk, because I'd be interested to know more about that. That's a
So
heck
out
of
of
a thing.
curiosity, what are some of the problems or the issues that you're encountering or people of the company are encountering that you're wanting to improve how it's working now?
Yeah, well, I'd say that we're actually trying to explore what the specifics are, because the leadership of the company felt that we were not thriving as a company. I don't think I'm sharing anything that's private here, really. But within different departments, like within engineering, I think there are some people that feel we're actually doing really well. We do a lot of async work already. We do a lot of writing. So I'm not sure if certain departments identify with that or not. And so actually what we've done so far just to get started was a survey to all employees. That was a remote work oriented survey. And we haven't, next week, I think we're going to be going through the results. And we're going to try to get more information about what might be working or not working from different departments. For example, sales or customer support, those kinds of departments. But I mean, I'd say like at a high level, I think commonly, with COVID and the pandemic and everything, and we've had a lot of growth at the company. I think there's some probably likely things to work on, which is just relationship building and trust building with people, and knowing what teams are working on and who to reach out to. And I personally think, I've worked remotely for a long time, and personally think that it works really well when when you have really good team alignment and really good inputs, and then you can just execute. You can just work, and you get to work kind of on your own schedule, and there's a lot of great benefits. But when you're confused about what the priorities are or who to talk to or that sort of thing, that's where I feel like remote work starts to become more difficult. So that kind of like one company that we've been talking about is HashiCorp. They have a really great writing guide online where they talk about like a couple of standards, for example, exploring problems as distinct from exploring solutions. I think they call it a problem requirements document. And they they have actually a number of different structures that we are kind of looking at as inspiration or things we want to adopt, maybe to help improve relationship building, trust building, mutual understanding of problems, and that kind of thing.
Cool. So Mark, you made it live to the show. That is very cool. Welcome, welcome. So he has a question for you, Andrew. I think going back to your initial thing you were talking about, how does the team decide when and how much to automate such outage scenario testing? Kind of an end-to-end test for platforms sounds like quite a task. Yes, it does.
Yeah, it is a big task. We are a pretty small team on the dedicated infrastructure and engineering team right now, like less than 10 people. So we can't really automate everything. We actually do make heavy use of Terraform to automate a lot of things, though. But as far as and I actually think this is often the right way to do it, is to do things manually first when it's easier to change things and you're kind of in a discovery phase.
Yeah.
So things like setting up replication, setting up snapshotting, trying a restore from a snapshot, trying a failover from a leader to a follower or a primary to a replica. doing those manually as an exercise first and working out the kinks is something that we're doing. And so what we're doing is we're kind of going, we have a broader plan, where we do want this all to be automated, but for this quarter, we're just basically focusing on doing these manually, doing it with like 2 engineers. So we know where to go, what the steps are. And then next quarter, we hope to do more automation.
Cool. All right, so we've all had some busy weeks, but all right. So Andrew, I want to talk about scaling. I'm really interested, but first, I want to hear a little about Andrew. What's kind of your path to this love for scaling things?
Well, yeah, I guess the not my current employer, but my previous employer, I joined in at a time period where I was able to where the product was used heavily. Well, let me take a step back. So I think in my career, actually, I haven't had a lot of opportunities to work on larger scale applications. I've worked at a lot of startups where there just isn't a ton of activity quite yet. And or actually one company I worked at with a lot of scale, they use MySQL. So I wasn't really a database oriented developer, a database curious developer at that point. I was just using it for basic stuff, using the ORM. I wasn't able to access the primary and do things, which I can now, for example. But the path, I guess, has been mostly application development in my career. I think it's been about, 2006 is kind of when I got my start. So however many years that is. But yeah, mostly web app development, and then increasingly becoming a more senior engineer, wanting to work on higher leverage tasks in part, like make broader impacts in my work. And I've always been, I guess, a little bit, I think like a number of things aligned for me. It was the biggest reason, though, I don't want to lose sight of is having the actual opportunity to do things. So let me go to a specific example now. So this company I joined, one of our first issues was we didn't have a dedicated database administrator, and we had some operational problems that are common from high growth database activity in Postgres, such as big bloat that wasn't really being addressed effectively with the built-in, automatic vacuum mechanism. So I had heard of auto vacuum, and I, pulled up the documentation page and saw there was a couple of parameters, but I didn't really know what I was doing. And people on the team, we had great engineers on the team, but no one was really focused on the kind of macro level, to use a term I've learned recently. Shout out to the Postgres.fm podcast. They've been talking about kind of micro level and macro level optimization. But so the kind of macro level look, like what is your overall, resource consumption like with aggregated queries, or like what is your operational problems? Like, are you hitting a lot of resource load from indexes that have very high bloat that are being very ineffective and need to be rebuilt? And it's not queries themselves, but it's more operational. So those are some of the issues that we were having. And I think I kind of started mainly with auto vacuum. And then I think I can name this person because I believe I have publicly before. But so I had the opportunity to attend an office hours regularly with a Postgres committer, David Rowley, really nice guy, really, really helpful. And it was an opportunity for employees at the company to attend. And I kept going, and at least several times, no one else was attending. So I just got to talk about my issues, and David just told me, and it was great. And
it is astounding. Now, was this all a focused discussion on Postgres?
It was, yeah.
And databases. It's astounding to me the number of developers that are like, oh, database, keep away, keep away. I don't want to go near you.
Yeah, and
I'm constantly astounded by that. But anyway.
Yeah, that's been part of it. I mean, I think, and I've built a lot of my career on Ruby on Rails, and I'm really appreciative of everyone that's built it. the philosophy, though, I think in the early days, or at least what I took away from it, was if you use the object relational mapper, if you use Active Record, you can do things like switch databases, or you can do things like not worry about SQL. And
the number of companies that actually switched databases are probably on the one
right.
hand.
Yeah, I agree. I've actually never. One company I joined said they had just switched prior to me joining, but I believe I'm still like, I don't know how to say it in a sports way, like 0 for 0. I don't think I've ever, the database has ever been switched where I've been working. Becomes really costly, and in terms of hours and opportunity cost and things. I mean, there's a lot of reasons why it's costly, but so most of my career had been using the ORM, and that's great. But when you run into, I think if you come at things from the other side, from an infrastructure perspective, systems administrators, database administrators, they're going to be thinking about disk IO, and they're going to be thinking about memory usage, and most of that I'm not claiming to be very knowledgeable about. I'm not, and but that's kind of the direction that I'm going now in. I'm kind of going from the application more towards the system level, but I also, I just kind of discovered that, like you said, Creston, there aren't, to some extent, I don't feel like it's not a very crowded space. Like, I feel like there's a lot of interest, and I'm sometimes surprised that people aren't more interested in the relational database management system, whether it's Postgres or MySQL or whatever, with some of the operational quirks and nuances. And so that's part of it. I would say one other quick thing, and then I'll take a breath, is I've realized about myself over time that I'm comfortable just telling people I'm the kind of nerd that likes to read the manual. Like, I got an e-bike recently, and I was genuinely really excited. I was excited for the bike, but I was also excited to read the manual. And I learned like 2 things from reading the manual. I learned how to read the power level from the battery that I wouldn't have learned otherwise. And then I learned about like a walk mode that it has, I didn't even know about. So I have realized that actually plays out in my career too. And I like to read the Postgres documentation and it's really well done. And so I think there's always opportunities to say, oh, this is weird, and why does it work this way? And then go into the Postgres docs. I'm also somewhat active on the Postgres community Slack, and will ask people things myself from work, from personal projects. I'll sometimes also contribute answers for people where I can help.
Cool.
Well, you're in close company. I like reading manuals as well. But I will say I have not read the whole Postgres manual.
I think on Postgres FM, they were talking about how big it is if you were to print it out, and I don't think anyone could. It would, you'd retire before you
I use Google, and then I read individual pages if need be.
That's better you guys than me. I don't have the patience for that deep dive stuff.
It's weird. And actually, one thing else, can I throw in one more thing?
Yeah, for sure.
Let me just make sure I get his name right before I quote it. I tell everyone about this book. It's it's Will Larson, his book, Staff Engineer. He talks about working on what's energizing to you. And I've been really kind of trying to think about that more the last couple of years, because when I work on something that is inherently fun for me anyway, I'm just bringing more passion to it. I'm just more excited about it. Like, I actually excited to read the Postgres documentation on my phone at night before going to bed, which is maybe a bad idea, but
because then your brain starts working on things.
Yeah, and that is a problem. I'm a big proponent of sleep hygiene too, so maybe don't do that. But
that's when you print out all those Postgres pages and then you read them.
I'm like, what is this function or whatever? But it's like I'm going to do it anyway, so I might as well work on things that are exciting anyway. Is kind of how I look at it, and then trying to find opportunities to do those things as part of my job expectations too. There's some mutual benefit there, like, it's what I'm going to do anyway. Hopefully it's stuff the company I work for is looking for me to do, and then it's a win-win.
Yeah, well, I think, the pattern I see is that is because there's so much stuff in development now. There are so many things that you need to know that as you get more senior, you start specializing in the different areas, and you this person becomes the JS specialist, and this person becomes the database specialist, and this person, and it's kind of funny to see the different likes of different developers, because you start out as, oh, I want to be a web developer, and then you end up in this very very narrow thing because that's what you've gotten really good at and that's what you really enjoy. And it's like everybody kind of ends up in a different little place. um it's just
Yeah, I agree. Yeah, I agree. I try not to be too cynical about it, but I mean, the reality is like, I just decided at a certain point, I just can't keep up anymore with front end development. And I was more of a full stack developer in the past, but it's not something that is as exciting or energizing to me. So I do really try to seek out job opportunities where I can be part of a team and I have that opportunity to specialize more. And I can say, and also I think being more senior, you become more comfortable saying like, it's totally fine. I don't know everything.
Yeah.
I maybe I'll know a little bit about, maybe I'll have some mental model about how it works basically, and I could maybe help in a crisis. But I'm part of a team where we have some front end specialists, some back end specialists, some infra folks.
Yeah. So let's talk to the audience a bit about how you scale things. Like where do you when do you say, oh gosh, we need to concentrate on some scaling here? And how do you start picking that apart to say, okay, I'm going to get the best bang for the buck for doing this thing?
Yeah, it's a good question. Actually, I believe the question more or less in that form came up too with the RailsConf talk, and um, I think I wrote this up on my blog. I can follow up with you afterwards too. But there was also this RailsConf home edition. I remember a conversation there where someone asked a similar question. How do you get started, or which things to focus on first, or that kind of thing. And there's a lot of different ways to use Postgres. So my comments will be more like based on Ruby on Rails web applications that I've used that are, where there's a lot of concurrent activity. And there's operational things like vacuum, but maybe just leaving those on the side for a moment. I think starting with let me just throw out some ideas, I guess. I don't have like a 1, 2, 3 playbook myself. But I don't know, maybe Creston, if you do, from seeing it, like I've actually been curious for people that consult with in Postgres and see a lot of different applications. Like if you just start to see the same stuff over and over and you develop a playbook.
My playbook is a bit simplistic, but it's like I look at PG stat statements. So first of all, if you have Postgres, make sure that you have the extension PG stat statements enabled. And what that does is records every query or statement that you're running in the system. And then you can just look at the top 10 that are taking the most database time. And there are other applications that do this for you. You can give it in GUIs or whatnot, but you could just use PG stat statements. And then I look at the top query and say, okay, this one statement is taking 20% of your database is spending its time on this query. So, okay, what can we do to make this faster? And then you go into depth as to, you could look at indexes. You could say, all right, are there bloat problems? Is it being called a lot because like you've got n plus queries or something? So it helps give insight that leads you somewhere else. So that's like the main thing that I do. Like, I don't know if you have examples that you've run into that you take it a different way.
Yeah, I think I also have learned about and recommend PG stat statements, and it shows you your. I really also like what the PG Hero tool adds on top of that, where it shows you kind of like a percentage look, where it uses a combination of the times that a particular normalized query is called. So
Yep.
the count and the duration. And then you can get more of I think it attempts to help show you the kind of like percent of impact. Like you said, the 20%. It's like, of the last 5,000 recorded normalized queries, 20, if there's a big percentage that's used up, then from an infrastructure perspective and resource consumption perspective, that's a good place to start. That could, from a scaling perspective, that could allow you to not have to spend more money to bump up an instance class. But what I'm actually running into more lately is more coming at it from the other side, which is the application performance monitoring side, like the APM tool. So maybe your organization uses New Relic or Datadog, and if you have particularly slow endpoints, there may be more interest in working on individual queries and improving them, and kind of maybe going from basic ORM queries to maybe writing SQL directly, or making queries more selective, where you look at what's in the where clause, or you look at the join conditions, and that can be impactful too for particular teams. Like if they have this one endpoint we always call is always really poor, and maybe it doesn't use a lot of resource load, but it's really slow and customers complain about it. Making a query fix there and shipping that can be more of a kind of a company win, even if it's not like moving the needle on the DB that much. And so I guess that's one thing that comes to mind. But and again, it depends too if we're talking about just Postgres or Rails and Postgres. So that comment was more about, like, I would say what Creston was talking about was like, if you're looking at just Postgres and it doesn't matter to some extent what the application is doing, where the queries are originating from, you're just trying to reduce the load on the DB server. Could be a PHP app or a Java app or whatever.
And a lot of my clients, I just don't work with Rails clients in my database consulting. I have people who are using PHP and some version of Node. I'm not quite sure which one. So so a lot of times I have to take it strictly from a database perspective. But I have other Rails clients I'm also using their APMs.
Right. But yeah, I do think that having an APM is important. And Postgres FM folks talked about PG stat statements being like an observability tool, which I hadn't kind of classified it that way before, but I think that that's what it is too. It's another perspective. It's looking at the aggregated queries, and then allowing you to make a dent in the resource usage for the database. So I think that's a good place to start for query optimization if your team has that level of, if that's appropriate for your team. And so I think that would be like if your role is a database reliability engineer, or if you're more of an infrastructure engineer, and you want to move the needle a little bit on the load on your DB server, that's a great place to start, is PG stat statements. You don't have to change anything. There's no new databases that are needed. So another thing though would be replication, and just Postgres. I think the challenging thing for me about scaling is knowing the audience and what the expectations are for that topic, because it's a really big topic that includes stuff way beyond the scale I've worked on, that would be like distributed Postgres with lots of primaries and that sort of thing. And I'll let you guys know I haven't really worked on that environment before. And the kind of scale that I've worked on is typically, I'd say the big things are replication, distributing the read load and the write workload between multiple databases, and there could be multiple readers. Partitioning, where the data itself has gotten very large, and it makes sense both to have a mechanism to remove data from the database and talking about retention and stuff, and we could talk about that. And then kind of like customer level sharding, where you might have the same schema, but you might have, for a particular customer, their database is running on its own database instance. So they have isolation, and they have the load for their usage is just for their, like the load on the database server is just based on their usage. And then I would say the other type of sharding is kind of like, I think it's called different things, functional sharding or application level sharding, where you might take a group of functionality and relocate that functionality, could be metrics or other kind of separable functionality where data is not joined heavily within the application, and that could also be run on its own database. And I talked about that, actually, an example from my workplace in the talk I gave last year at PGConf NYC, which was my first ever Postgres talk. And there was a bit on that. So I can talk more about that if you'd like as well. But I'd say that replication, partitioning, and then some kind of distribution of the tables where it, if you have a pattern where you have really, really high writes on these handful of tables, it might make sense to put those in their own database. Or especially if you're running a software as a service application and your customer is paying for it anyway, or they're asking for it, running their database on its own instance is an option as well.
So let's take a little break for chat. Catch up with the chat here. Colin, hey, welcome, man. Good to see you. I saw you guys had a lot of fun with the hackathon this weekend, so good on you for doing that. Mark Clifton, distributed systems, setting info up to be unidirectional helps a lot, and using known unreliable communication styles like PubSub. I agree. Yeah, especially with one of the things that we did to help with some scaling and some performance issues in the database was to make the data non-updatable. So it's all just, it gets written in there. Yeah, immutable. I don't like big words. I'm a simple dude. But yeah,
four syllables. That's where my brain shuts down.
Right. Yeah. But you put it in the database because writes aren't that expensive. And then you just keep adding to the database. So it's, like things where we have to keep an inventory level. We just keep adding to the database, and then we'll just read it out and sum it, because that's much faster than trying to update. Mark, hey Chris, we're at the 35-minute mark, making sure time does not catch you off guard. Thanks, man. I appreciate you looking out for me. That's something I just have a problem with. But yeah,
the great thing about insert-only tables is no locking.
Yeah. Mm-hmm. So and it did make a big difference.
That's what makes it super fast.
Right. And he also said +1 to the customer sharding. Find out your shared data patterns should help a lot with things like vacuum index bloat. Yeah, we actually do that where I work. We have several customers that are really, really big, and if we put them in our shared environment, they would just obliterate everybody, and nothing would ever run. So we do have several big customers that have their own database setups. And we keep them segregated, and even then it's kind of tough to keep them running well because they're just huge. I mean, millions and millions of records every month going in and out of that thing, and it's a little rough to keep up with. But yeah, the customer sharding, if we weren't doing that with the database, the whole system would just come crashing down.
And in case people aren't aware, we are not yet on. So where I work, we use Ruby on Rails primarily. We have a number of different services, and our primary service is not yet on Rails 7. But I'm really curious about I think they call it horizontal sharding. I can send a link about this too, but I'm not sure if anyone on this call is using this yet, but you can the Rails guides actually are a really good source of, if you wanted to introduce this for your application, if you did have that particularly spiky customer use case with really high growth tables or really high query volume, and you're running Ruby on Rails and you're relatively closer on Ruby, 6.1 or 7, it might be worth a look into as a way to help distribute that load, to be able to use the built-in multiple databases functionality, which you can use for other things as well, but to be able to use the horizontal sharding functionality.
That's interesting, because we are getting ready to start the upgrade to Rails 7 progress. That's going to be a path, but yeah, I hadn't really read up on that, so that's something I'll definitely want to take a look at. I don't.
So what you're talking about, that's the ability where you can say this particular model was stored on this particular database. Is that what you're referring to?
Yeah, you can say, you can do, yeah. So I think I actually just pulled up the documentation here, and
so it's a way of functionally scaling. So you're saying this functional unit goes in its own database and this functional unit goes in its own database.
Sorry, Colin, I was wondering what the hell you were talking about with snarfing. I'm glad that was just a typo, because I'm like, that's not a term I've heard, dude.
You done snarfed it up. Okay.
But
so
Colin,
yeah, I have some clients who are actually doing that with Ruby on Rails.
Oh, cool.
So yeah.
So yeah, Colin says, don't remember exactly, but isn't there vertical and horizontal partitioning? If that's true, just curious as to when you would maybe reach for that. That's actually kind of a good question.
Yeah, so partitioning isn't something I had done at all until my current job, but we do use Postgres's native partitioning functionality, and we use the both. Actually, we only use currently the range partitioning, and there's also another type called list partitioning that we are looking at using, but we don't currently use. I can talk about like where I think we could use it, but for range partitioning, we have this whoops, somehow I just shut my video off. Sorry about that.
It's all right.
We have the great thing about range partitioning is we have this use case in the application where we have this really high write volume table, where we get around 1 million rows per day written into this table, and the application exposes this data for customers to be able to query it. But the application only lets you select up to a week back. So this was set up before I joined, but the database administrator set up a daily partition where new rows are written into a day view. And what that lets us do is for days that are older than 7 days, we don't really need those to be exposed to the application. So we have options. We can do, and Postgres lets you detach, and you can detach concurrently as well as to not interrupt other transactions. But you can detach the partition, and then it just becomes kind of like a regular table. So a partition from 2 weeks ago could just be hanging out as a table, or you could do things like remove it from the database entirely. You could use PG dump and dump it and put it into a file and encrypt it and throw it on S3 and forget about it. You could relocate it to a different, you could relocate those rows to an archive table. So there's different options there. And the nice thing is it keeps the query performance. There's a number of benefits. It's mainly about data retention though, primarily, and about knowing what the application needs for the data. But then it's also about performance and scaling, because we don't, it's from a performance perspective, as long as we make sure the queries always include information about which partition to use, so we know what the day boundary is and make sure that that's on the where clause of the queries, then we can get better performance than an alternative where there wasn't partitioning, where we might search across many more rows by being able to drill into those specific partitions. So we'll get better query performance. And then if there are updates, although in this case it's an append only table, we don't update this table, the one I'm thinking of. But if there are updates or deletes on rows and you're using partitioning, the other benefit operationally is that vacuum can run concurrently across partitions. So you can get better vacuum performance as compared with if all of those partitions were in a single table. You can have multiple vacuum workers on that table and that sort of thing, but you're not going to get the parallelism benefit from having that data distributed across partitions. So we're trying to do on the more, again, I'm not a database administrator, but I'm like kind of a hybrid app developer database person on the team. And one thing we're trying to do is just encourage more use of Postgres' native partitioning, and encourage more thinking about data retention. Do we actually need all of this data forever? What are the queries actually doing with this data? And in a way you can, it's related to scalability, because if you kind of have an understanding of the growth pattern of the data, it helps with having more predictable performance over time and not necessarily needing to scale up or scale out later.
So I missed a question from Mark here. Perhaps turning synchronous commit off could be acceptable for a worker style DB that doesn't need guarantees. Thoughts on that?
I'm aware of synchronous commit, but I thought it was off by default. My understanding of synchronous commit was if you use replication, physical replication, and it's commits, the transaction is committed. For example, if you're inserting a row on the primary, it wouldn't be dependent on the Creston, jump in and correct me if I'm wrong here, but if there's an insert on the primary that is replicated to a replica, and I thought synchronous commit was off by default, and it would only be used if you wanted to ensure that the transaction wouldn't be committed until it was confirmed to be replicated. But by default, async, the replication is async and doesn't work that way.
Yeah, between replicas, by default, it's async. You have to explicitly tell it to be synchronous. But I think synchronous commit may be referring to actual disk writing. I'm trying to remember.
Just going to sit here and stir my water while you big boys talk about the cool
Yeah,
things.
so synchronous commit that's the setting has to do with the write ahead log. And generally, I don't ever turn that off. But like you said, if you're not too worried about any sort of guarantees that the rights were made to, but anyone that I work with is pretty much cares about their data. So normally I haven't set synchronous commit off.
Yeah. Right. So one of the things that I wanted to kind of ask you that I had been thinking about is when we start running into performance issues and we're starting to investigate those, usually the first place I go is to the database. Do we have query problems? Are we missing indexes? Or do we have inefficient queries? And most of the time, it's something in the database layer that gets the best bang for the buck. Has that been in your experience?
I got a little distracted by reading about the common use cases for turning synchronous commit off, which I was starting to think like, oh yeah, I could see that, the migrations, and we could maybe come back to that. But Chris, yeah, you were saying, yeah, I mean, at a let me just restate what I think you said, because I was getting distracted. But you said often when you investigate at the APM level performance problems, like it's often the database, it's due to slow queries as being a big proportion or a big percentage of the total. So like, let's say it's you want API to respond in 50 milliseconds, but it's taking 500 milliseconds, and you realize that 400 milliseconds of that was the database query, something like that. Is that what you're saying?
Right. And I've just kind of gotten into the habit of, hey, we got a performance problem. Let's look at the database first.
Yeah. Yeah. I think what I'm realizing is I think talking about partitioning and replication is probably off-putting for people that are on more like, wait a minute, what about the basics here? So like the first thing, well, so again, kind of, and also I think there's that I really like that micro analysis versus macro analysis distinction that, and because we talk about that on our team as well. So on a micro level, which could be maybe an API endpoint, but let's just say now we've zoomed into a particular query, then yeah, there's a learning curve involved, but being able to take a query example, if you don't have the exact parameters and coming up with parameters, that's a whole nother topic. But let's say you have an example query in your APM. So it has values in it. It's like, let's say it's selects a few fields, it joins a few tables, it does some filtering, it does some ordering, and it does some limits. So taking that SQL query and learning to use explain, analyze, and the very basics to me is learning to identify whether index was used for a query or not, where you're filtering rows. And so identifying, if a full table scan or a sequential scan was happening for a portion where either you didn't know if an index was in place and you thought it, or you did know it was in place and you're surprised it's not being used, then I think going in and saying, okay, we're always filtering on the account ID field. Let's make sure that this table has an index on the account ID field. And typically if you have more database privileges, you can actually even just experiment a bit with that. You can, probably not a good idea in production database, but if you have, you can, but you can, you can do things like, well, you can just add and drop indexes, for example. You can add an index concurrently and take a query before and after and make sure it uses the index, and it's much faster. Best to do that in a pre-production environment.
I love clients that have a separate machine that has a copy of their production database.
Yeah.
So that you can have the exact data at the right volumes, and then you can do that type of analysis to figure out query problems or what's the best index or et cetera.
Yeah, exactly. Yeah. And I really have learned a lot from and appreciate Lucas Fiddle's writing on this too. So I'm going to call him out too. And he gave a webinar or something recently I was watching where, it's like indexes are a trade-off between disk IO and retrieval speed. Their main purpose is to speed your queries up, but they also involve the maintenance of indexes when they're not used, or when they're not optimal, or there's overlap or duplicates. That can actually generate a lot of excess disk IO. So it's something to be mindful of. And what I often see is too many indexes that are not used, and duplicates and that kind of thing. A lot of times people will just kind of YOLO an index out, like, hey, I think it's this, like, I'm just going to ship 3 indexes here, and this, or they'll create brand new tables with indexes, which, like, maybe it isn't really clear that they'll ever be used or needed. So I'd say the common problems are, missing indexes. And then the other thing that can happen over time is indexes and table data becomes bloated, and it's not laid out efficiently on disk. And for indexes, the way to address that is to rebuild the index. And Postgres, I think it was 12 and newer, you can do that online. So you can do that. you can even automate it. And in fact, where I work, we do that. We actually just automatically rebuild indexes periodically. And if we're faced with a particularly slow query, we often will first eliminate, and I've kind of learned this from we do have a dedicated database administrator as well, but there's, kind of eliminate the low hanging fruit that is the database level stuff where it's like, what's the index bloat? Like first, is there an index? Is the index bloat okay? When's the last time that table statistics were collected? Like when or when analyze was run on the table? When's the last time the table was vacuumed? So we kind of clear all that up, make sure that's not actually the problem. And then that you have, if you know that there are indexes that match the where clause of queries, and that the table doesn't have high bloat and the statistics are updated and the indexes don't have high bloat, then and ideally you have a pre-production environment like Creston said, which has similar database size and similar data, then that's kind of like, then you're in a good spot where you haven't fixed the problem yet, but you have all the ingredients that you need to fix the problem. That's been my experience. And that sometimes, then at that point, then you want to look into the kind of query level optimization. But let me take a breath because I've been talking for a long time.
Yeah. So, and one of the things that Colin asks, typically try to add indexes for columns ending in ID and for queries that run all the time. Any other general guidelines on indexes? It's kind of hard to do general guidelines on those because do I want to add a bunch of individual indexes? Do I want to add compound indexes? It kind of depends on how you're using that data and how it's laid out in your application and how you're querying it together. So,
well, whenever I create a new table, of course, the primary key is going to get an index.
Sure.
And then the foreign keys, which is exactly what Colin said.
The IDs.
_ ID and Rails.
Right.
And then just run with that. And then when you see slow queries, then you say, all right, we're going to need to do some changes here. Or if you intuitively know this is the main query and it's going to need something to make it more efficient. But then you let it run and then see how as the table builds and grows and columns are added, then you can, make changes.
Right. And one of the things
that's what I do.
Yeah, one of the things that I've learned, and I think you were kind of alluding to this, Andrew, is you don't want to just like preset all your indexes and say, well, I think maybe someday I'm going to use this in this way, so here, let's throw an index on it early on. You just want to add indexes when you find a problem. So I think, yeah, you just want to, I mean, like you said,
indexes are costly in size too. And if you have 100 gigabyte table and you have 10 indexes on it, you can easily have, I've seen indexes that are bigger than the table, like, I don't know how common that is, or Creston, if you've seen that too, but it's kind of a mind bender. It's like, wait, what?
Right.
Well, it's, it's a slightly different structure than the heap. So I've seen it when the table has very few columns and they wanted almost every row to be unique. So they have essentially unique index over across the columns. Well, now your index is bigger than your table.
Yeah.
Yeah. That's, oh my gosh, that's painful.
And also too, there is, I've learned that, and I don't have a good example, although I actually really want to develop one, but generally the guidance that I've learned is to prefer, going back to the question about single column indexes versus Postgres, in the docs, they call them multi-column indexes. I think in MySQL, they are commonly called compound. I know I've seen the word compound a lot too, but
yeah.
Postgres
MSSQL uses compound too.
Yeah, multi-column. There's also partial indexes we could talk about. And then these are all the B-tree indexes too. There's also other index types to talk about. Yep. But I think for bang for buck, like my mindset is usually to prefer single column indexes and not multi-column indexes, because there can, like, indexes for even if multiple columns are used, Postgres, my understanding is can utilize indexes on single columns together as part of one query execution plan.
Right.
And
to a point.
Yeah. But I do think I also agree with the advice that it's really hard to provide general advice on these, and the best thing is to always test it. And even you can actually even test it locally too. Like I have a MacBook, I have Postgres running locally. I can fire up PSQL, and I have some details about this, and you can always hit me up on my blog if you want. But developing at least some methodology, if you work in this area, to be able to insert 1 million rows into your local database and take a similar query and run it, and then experiment with just creating indexes. Like let's say I want to test if the query execution time, if you want to do that kind of individual query analysis, there's nothing stopping you, and you're not interrupting any production traffic, and you don't need any special access to do that locally on your computer on a local Postgres. And what you can do is you can manually run the create index statements. You could do it via Rails migration if you wanted to, but if you spend some time to learn the SQL, and you could create a single column index and then a multi-column index, let's say with 2 columns that are part of a query, and you could just test locally, and you could at least get a relative difference to the benefit between those 2 approaches. And that's something I've done too at work. Like there's been times where it's too much of a ordeal to test on. I'd get enough information from kind of a quick local test, and so I'll use the generate series function that Postgres provides as a built-in function, and generate like 1 million dummy rows to start to get to a reasonable size of a table, and then run a query. Like I want the query to actually take a little while, to take like 10 milliseconds or 20 milliseconds or something. So you might have to generate 10 million or 100 million rows locally or something to get there. But then you can, and then also your create index statement is going to take a while to run, but not too bad. And you can just test it, and you can say, okay, with this version, I can get it to, and you want to run it a few times, but I feel like that's kind of a naive, basic local benchmarking approach, where if you run it a few times, you kind of could get hopefully some difference between those 2 that then you could take to a production environment and hopefully reproduce those same results.
I think too, it's kind of good to deep dive into how indexing works on a database, because knowing like there's big differences in how you lay out your data and how you can fix data problems, not just by adding an index, but knowing how and when to add the indexes. Like integer fields can be indexed much more quickly than text fields. So if you've got something that can be stored as an integer, do that. If you've got low parity on a field, if you've only got 2 possible values in a field, it may be counterproductive to put an index on that field. May actually make things worse in a lot of cases. So understanding how they work is kind of important too, to figuring these things out, I think.
Yeah, definitely. I think it's worth anyone that works regularly with a database doing application development, the unique values in a column, like you said, can be really informative, and you can get that out of Postgres itself with the statistics it collects. You can look at is it the PG? There's a system catalogs view that shows you the most common values when analyze runs, and you can always just run analyze table name to update those statistics. And if you have an index that is not very selective, it was surprising for me when I learned this, and I think it's surprising for everyone at first, but you can have an index on a field where Postgres at query execution time will say, it's actually slower to access the index, find the rows that I need, and then go and get those rows, compared with just reading all of the rows. And it will just not use the index, and it can be confusing as to why. And I think that's a good thing to learn, and then keep in mind when you're making that decision of, is this index beneficial or not, to think about, well, what are the values in this column that I'm filtering on, or that kind of thing.
Yeah, and that's typically like booleans or a lot of times status fields. Maybe there's only a handful of status fields. But a cool way to get around that if you need to is you can actually do a partial index, which partial index means it's only going to index certain rows of the table. So you could create, in case of a Boolean, you could create two partial indexes, one where it's true, one where it's false, or statuses. If you only care about, say, three of the statuses, you could put partial indexes on each of those three statuses. And now it can, the only thing in that index is that one status. So it can very quickly go in and use other columns to pull data.
Yeah, that's a good point. I hadn't done the multiple partial indexes before, but that makes sense. I have done the, I have like replaced an index with a partial index where the, the queries all had an expression that could then just be baked into the definition of the partial index. And then the big win there was the size reduction of the index.
Oh, yeah.
It's gonna have some pretty dramatic differences. Again, if you have a 100 GB plus table, or I know there's even bigger tables, and you have a 100 GB index, and you can replace that index with a partial index, you can potentially cut it by a tenth of this. You can make it the tenth of the size. It depends on how many rows you can exclude with your expression.
So when we talk about scaling in general, from a web development perspective, or an app development perspective, most of the time what we end up talking about is database scaling. Is that fair to say?
Yeah, I think it's the. I mean, that's been my experience at a lot of companies that choose, they might be running into performance problems because there's a lot more usage of the application, and maybe the application, like in Ruby, you might have a lot of additional application servers running. Like if it's Puma, you kind of scale at the process level. You have a lot of different processes, but there's going to be this point where everyone needs to, if you have a single database, if you go from 50 to 100 web application servers, but you have the single database, there's going to be more resource load on the database. There's going to be more concurrent activity. The data is going to be growing, which can cause challenges in and of itself, like operationally. So yeah, I think I think what I still kind of feel like to some extent I've been exploring this for about 2 years now, where the exploring, I guess, where I want to go with, I think I know there are these positions at companies, these database reliability engineers, where you kind of focus on some of these problems. If you're at an organization where you have enough specialization and it's important enough to fix some of these problems, you might be introducing replication for the first time, or you might be introducing both physical and logical replication. You might be working on partitioning. You might be working on index management. You could be introducing additional supplemental databases. Like there's so many things to do. There's also, we haven't really talked about, and I don't really know a lot about this, but there's Citus recently, actually Creston mentioned this recently, I think in your last Scaling Postgres podcast, is now open source as a multiple as a cluster where you have multiple writer databases. And I shouldn't talk about it much because I don't know much about it. I do have experience with a cluster of multiple writable nodes with Elasticsearch. But I think that's also part of the story too about scaling, is it's at the end of the day, it's resource consumption on one or more servers. And you can do a lot of things, like you can reduce the resource load by making the queries more efficient. You can relocate the query load to more servers. You can actually replace you can rewrite queries, you can relocate functionality to an entirely different database. I think a lot of organizations, they don't solely use Postgres, I mean, some places do, of course, but
We've got a mix. We've got
yeah,
some services on Postgres, and the one I work with is on MySQL, and and then of course we've got Redis and stuff going on. But so yeah, and so to the junior devs that are listening or watching here, very important. Spend some time learning database stuff. As you move in your career, you're gonna want to know how databases work. You don't have to be the database expert and know everything about your database, but having some fundamental ideas about how SQL works, how indexes work, how your database pulls and reads and writes and stores data. It's important to know that stuff. So make sure you spend a little bit of time on that, even if you're a front end developer. Having a little bit of experience with that stuff is a good idea. Oh my gosh, listen, Mark, I didn't get my 60-minute bell here, so you know what? I'm not the only one that gets wrapped up in these conversations. See? Not just me. But man, yeah. But yeah, I did really enjoy this. This is fun stuff, and apparently chat enjoyed this too. So they were really active. So we appreciate that, chat. We love when you guys are active. It makes our conversations more fun and makes my job a lot easier because I don't have to think as much. So that's great. As much as I'd love to spend another hour and a half talking about this, we kind of can't. So Andrew, thank you very, very much for taking the time to be with us tonight. I do hope that you'll consider coming back and spending some more time with us talking about database stuff, because this is obviously a subject that we could spend years talking about. So I had a lot of fun with this conversation, and we really appreciate you being here.
Yeah, thanks.
Chat.
Thank you. Yeah, I would love to. Yeah, and I can hold it for a minute, but I wanted to recommend some more resources too, if that's appropriate, or when you have a break.
Yeah, go for it.
Or I could do it right now.
Go for it.
Well, I was just going to say, for anyone that's watching this now or later, if you want to get some kind of immediate feedback on things, there's the Postgres community Slack is really good, and there's a lot of different channels. There's even a channel for newbies, or I don't know, it's sort of like newcomers to Postgres. And there's also some really advanced topics in there too. So there's a huge range, and there's a lot of folks in there that are visible within the Postgres community, meaning that they speak at conferences, or they've written books, or that sort of thing too. Someone asked about query analysis. There is PG Analyze, Lucas Fiddle's tool. It does have a free version, which is worth checking out. And then, yeah, feel free to reach out to me as well. I like to talk about these topics, and I'm available on Twitter or through my website. You can contact me. Yeah, thanks again for the opportunity, Chris and Creston, to join you guys.
Yeah, it was a great conversation.
Yeah, it's fun.
And chat, thank you very much for being here tonight. I hope you enjoyed that. If you did enjoy this and you're listening or watching on YouTube, please make sure and mash that subscribe button and give us a like, because it helps other people find us. Comments are always welcome. We will respond. I know a lot of the comments come through the live chat, but hey, if you got something after the fact that you think of, just throw it in the comments down there. If you're watching this on Twitch, please make sure and smack that follow button. All those things are free. All those things help us out, and they make me feel really good about myself. So do those things. Also tell your friends, bring your friends along. The more people we have here in chat, the more fun these discussions get. So make sure you do that. We are here every Wednesday night at 8 p.m. Eastern time. We attempt to have a guest every week. So if you like to see somebody particular, hit me up on Twitter at DuckyDevShow. You can find us there. I do a little bit of that there twittering, but you guys have seen me there. Anyway, we will be back next week with, oh gosh, I didn't even look. Who have we got next week? We have got Ernesto Ernesto's coming back to talk about code quality. And last time he was here, he talked about the tools you use. Now we're going to talk about, okay, now we've got the tools. What do we do with it? So that'll be a fun discussion. So thanks for being here. We will see you next week. And until then, happy programming.
Happy programming.
Bye.